Okay, let's take a look at some chain rule problems, and specifically some that are a little more challenging, where I think it's good to use U-substitution. It kind of helps you evaluate the problem. But you know, the basic chain rule here, right, is that we kind of do the power rule of what's inside the parentheses. So we bring the exponent down, multiply it by what's in front, subtract 1 from the exponent. But then the chain part is that we do the derivative of what's inside the parentheses. So I'm going to show you a way to do that when you have some special cases where it's a little bit different. So let's dive right into it. So if we're looking here, right, you could just do the chain rule. You bring the 3 down, this becomes 2, take the derivative of the inside. But if you want to use kind of the U substitution approach, or just kind of thinking of this as U, well, 2x to the 5th minus 3x du, or the derivative of that, would be 10x to the 4th minus 3. Okay, so let's rewrite that. 10x to the 4th minus 3. So what we're going to do here then is we're going to go ahead and use it. We're going to say, I want to rewrite this as f prime u here. Well, let's just say f of u, and that's going to give us u cubed. And now we're going to say f prime u, and that's going to be 3u squared du. Okay, but then I'm going to go ahead and put back in the u and write it in terms of x. So we're going to get 2x to the 5th minus 3x squared, and then we're going to have 10x to the 4th minus 3. Okay, now it wasn't completely necessary in this case, but it does help out, I think. And so then we're going to go ahead and just simplify this a little bit. We're going to multiply this last term here in parentheses by 3 and write it in the front. So we're going to have 30x to the 4th minus 9. And then we have 2x to the 5th minus 3x quantity squared. Okay, now let's look at it with a special case, which is where I think it really starts to help out. So we're going to pretend this was in parentheses. Really it is. And we're going to have our u then will be 5x cubed minus 18x. And then our du is going to be 15x cubed minus 18. Okay, so now if we look at this in terms of u, we're going to get e to the u, and when we take the derivative, it's going to become e to the u du. Okay, so there's the derivative part, but then we can just go ahead and rewrite it in terms of x, and we're going to have e to the 5x cubed minus 18x, and then we'll have 15 our du, which is going to be 15x cubed minus 18. Now I guess you could rewrite this in the front, but really that problem is done there. Let's do 2 more of these here. So let's look at this one. We have the natural log of 4x cubed minus 5x. So we're going to, again, call what's inside the parentheses is going to be u. So 4x cubed minus 5x, and then du is going to be 12x squared minus 5. And then we're going to have our equation in terms of u, which is just going to be natural log of u. And then we're going to have f prime u then would give us, well, we would have 1 over u du. Okay, so 1 over u times the derivative. Okay, so let's go ahead and rewrite this then in terms of x, and we're going to see something a little more interesting happen here, where we're going to get 1 over 4x cubed minus 5x, right? So we have that, and then times 12x squared minus 5. And then we're going to rewrite this one final time, because really this is in the numerator. And so we're going to say this is 12x squared minus 5 divided by 4x cubed minus 5x. Okay, and you could look at it if they all had x, maybe you could simplify this more, but in this case, there's nothing more you can simplify for this one, so this one would be done. Okay, let's look at this one. So we got u is going to be what's inside the parentheses, right? And so that makes du 12x minus 2. And in order to think of this one in terms of u, well, it's just going to be cosine of u. And so then we're going to say, okay, well, f prime in terms of u is going to be negative sine of u, and then we're going to have that du at the end, which is outside of this, right, separate from the sine part of the function. So then we're going to go ahead and rewrite this in terms of x. So we're going to get negative sine 6x squared minus 2x. And now the tempting part here is you're going to want, like, this is going to be after, right? Here's my du. You're going to want to multiply these together, but you can't do that really because the sine is its own thing, right? That's its own part of the function. And because this is part of the sine function, you can't just multiply this. But what you can do is multiply the 12x minus 2 by negative 1 here and go ahead and write it in the front. So that's going to turn the 12 negative. And then this is going to be plus 2. And then we have sine of 6x squared minus 2x. I guess you don't really need the parentheses anymore, but I feel like this just kind of helps it make it a little clearer. Okay, let's look at, let's see if we can do two more kind of quick ones, and then we'll be done with this idea. Okay, let's look at this one. Now, this is a good example because this one you kind of got to rewrite before you can consider what to do with it. And really, when you see sine to the power of 4x, really what it means is it's sine of x to the 4th power. So my u is going to be sine of x. Okay, and then my du is going to just be cosine of x. And then if we look at that, right, now we can write this in terms of u. We got 5u to the 4th, so we're going to go ahead and take the derivative here, 20u cubed du. And then I'm going to say, well, then f prime of x, now we're going to write it back in terms of x, is going to be 20. And we can go ahead and now write this 3 like we have here at the beginning of the problem. So the u was sine, oops, let's see, sine cubed x, right? Sine cubed x, and then times cosine of x at the end here. So that's the du part. Okay, so this one, there's nothing more to simplify here, so we would be done. Okay, last one. Let's look at this, right? So we got 6, and we have this written here in the denominator. Now, you could, I guess you could use the quotient rule, but I think it's almost easier to just do this chain rule, and you just make the 3 negative here, okay? So, again, my u then is going to be 4x squared minus 9. And my du is going to be 8x. Okay, so if I think of it in terms of u, we got, first we have 6u to the negative 3. So we're going to bring that negative 3 down front when we take the derivative. So negative 3 times 6 is going to be negative 18. We've got to subtract 1, which means we get negative 3 minus 1 is going to make this negative 4 du. Okay, so let's go ahead then and write this in terms of x. And we're almost done here. We're going to write this in terms of x. So we're going to get f prime of x equals negative 18 4x squared minus 9 to the negative 4. And then our du is 8x, right? And so if we have 18 times 8, what would that give us? That would give us negative 144. Let me think about that and make sure. Yeah. So we could rewrite this as negative 144x. And we could just leave this as a negative. You could just write it like this, right? Or sometimes people would put it back into the denominator. And if they did that, you would get f prime of x. And you would have negative 144x divided by 4x squared minus 9, and then that would be to the 4th. Okay, so now we're done with this one.